In this lesson, we are going to discuss pH and pH calculations. Our objectives are to understand what a logarithmic scale means, to understand that the pH scale is a logarithmic scale. We should also be able to calculate pH, pOH, concentration of hydrogen ions, and concentration of hydroxide ions, and understand concentration notation. So first off, concentration notation is when we have brackets around the formula, and that means the concentration of that substance. For instance, H plus in brackets means the molarity of hydrogen ions, H plus. So that's a pretty simple, or if you had concentration of OH minus, that means concentration of OH minus. So in molarity. Moving forward, pH is defined as the negative log of the concentration of hydrogen ions. And this log means you're referring to the exponent. You're not referring to, it's not a linear scale, it's a logarithmic scale. So that's why they call it that, because you're referring to the exponent. For instance, my example over here, if the molarity of H plus is 0.01, the pH is the negative log of that concentration. So the exponent of 0.01 is negative 2, and negative 2 is positive 2. So the pH of that solution is positive 2. So, for example, over here, what is the pH of 0.005 molar nitric acid solution? Now, nitric acid is a strong acid, so we can do this. So we can do this equation with strong acids. Now, it's a little bit more that we're not going to get into if it's a weak acid, but let's calculate that here. So pH is equal to the negative log of the concentration of hydrogen ions. Here, since it's a strong acid, my concentration is the same as my hydrogen ion concentration. So negative log of 0.005, and I can type that in my calculator, and I get 2.3. Now, does this answer make sense? Now, let's compare it to the pH of 2 up here. Now, that concentration is 0.01 molarity, H plus ions. Here I have a lower concentration of acid, so my pH should be higher. So it's less acidic than my pH 2 up here. So that answer does make sense. My hydrogen ion concentration right here, if I want to know that, given the pH, well, that is equal to 10 to the negative pH. So, for example, if my hydrogen ion my pH is 3 right here, my hydrogen ion concentration is 10 to the negative 3, or 0.001. And we'll do some of these. The other equation is the product of the hydroxide concentration and hydrogen ion concentration is 1 times 10 to the negative 14. That's Kw. That's the water constant. So if I know one of them, I can calculate the other. So, for example, if my pH is 3 up here, now let's use the previous example, my hydroxide concentration times my hydrogen ion concentration equals 10 to the negative 14. And I can refer to some of my exponent rules. And my concentration of hydroxide is 1 times 10 to the negative 11th. Let's go down. The last formula we have is the sum of pH and pOH is 14. So if my pH is 3, my pOH must be 11. And then I can go and use my last formula down here. The concentration of hydroxide ions is equal to 10 to the negative pOH. So I have my pOH up here from the previous problem and previous example. And I can get that it is 1 times 10 to the negative 11th. Moving forward, so let's, I have a little graphic organizer on the second page here. And this just outlines all the processes and shows how everything's connected. So if you know the hydrogen ion concentration, you can use this formula here. to calculate the pH. Or if you want to calculate the concentration of hydrogen ions, you can use the pH to calculate that using these formulas. Similar to that, you can use the arrows and follow the arrows to find what you want to find. So the purpose of this is if you know one, we can calculate the rest. We can know what all of them are. So for instance, let's say my constant in this example up here, my concentration of HCl is 0.05. Hydrochloric acid being a strong acid, meaning my concentration of hydrogen ions is 0.05. Let's do all of them. My pH is equal to my negative log of this. And that's equal to 2.3. I believe we did something similar to that in the last question. In knowing my pH, I can calculate my pOH down here. I know the sum of pH plus pOH must be equal to 14. So 2.3 plus pOH is equal to 14. So I can easily solve for my pOH, subtracting 2.3 from both sides. 14 minus 2.3, and that is equal to 11.7. And if I know my pOH, I can use the other last equation here, calculate my concentration of OH minus. Or I can use my hydroxide. Either way, it doesn't matter. And you guys might talk in Algebra 2 about why those properties are. And if you're interested, you can come talk to me and I'll show you. It just has to do with the log properties. So my concentration of OH minus is equal to 10 to the negative pOH, which is equal to 10 to the negative 11.7. And I can use my calculator to calculate that. And I get 10. It's approximately 2 times 10 to the negative 12th. And I can also get that from using this equation over here. So, as you see, there's a bunch of different ways, but the key is here, if you know one, we can calculate the rest. So, given the pH, given the hydrogen ion concentration, we can calculate pH, pOH, and hydroxide ion concentration. All right, guys, we'll be doing a bunch of these in class, so get used to them.